All right, let's look at the homework 7, problem number 9. All right, so we want to find the critical numbers of this following function. All right, so first thing I would do is I'm going to rewrite this function. 7 is 7. Right, I'm going to write 9 over x as 9x to the negative 1. Plus 27 over x squared is 27x to the negative 2. All right, then we can take the derivative. So f prime of x is equal to, right, derivative of 7 is 0, and derivative of 9x to the negative 1 is negative 9x to the negative 2, right? And let's see, derivative of 27x to the negative 2 is negative 54x to the negative 3, right? So this is going to be, first I'm going to pull out the negative 9. So you have a negative 9, right? We have, let's see, 1x to the negative 2 power is 1 over x squared, all right, and pull out the negative 9, so it's going to be plus 6 over x cubed, right? Then I'm going to take the common denominator, so it's a negative 9, then common denominator would be x cubed, right? So you have to multiply top and bottom by x, so you have x here, and plus 6, right? So if you set that equal to 0, we can see that we have to make sure that the x plus 6 is 0. So we have x equals negative 6. So this is going to be our critical number, right? X equal to 0 make the derivative undefined, but 0 is not in the domain, so 0 cannot be a critical number. All right, so it's negative 6. Check the answer. All right, we got that. All right, so we want to find the increasing, decreasing interval. All right, so we just need to look at the sign of the derivative. All right, so let's do a number line here. So I'm going to draw a number line there. All right, so I'm going to actually mark 0 because a function is not defined there. And the negative 6, so actually I probably have to put the 0 here. And I put the negative 6 there. All right. All right, so we can just try any number less than negative 6. So we can try just the f prime of negative 7 or something like that. All right, so if you plug in negative 7, numerator is going to be negative here, but multiply by negative, so that makes it positive. But the negative 7 cubed is going to be negative. So there are 3 negative things multiply and divide together, so it's going to be negative. Right? So we have a negative sign. So we know that the original function f is going to be, this is right here, is going to be a decreasing here. Right? And let's try anything between negative 6 and 0. So we can try f prime of negative 1, right? So negative 1 plus 6, that's positive. Negative 9 is negative. Negative 1 cubed is negative, so it's going to be positive. So it's actually increasing there. So we know that this is increasing there. All right, how about a positive number? So if you try f prime of 1, right? So 1 plus 6 is positive, 1 cubed is positive, negative. So this is going to be negative. So we know that the original function is decreasing on that interval. All right, so the increasing interval is between negative 6 and 0. So let's type it in. So it's, let's see, we have interval. We have negative 6, let's see, negative 6 to 0. I cannot include 0. 0 is not, a function is not defined there. All right, so let's check the answer. All right, I knew that they're not going to like this one. I think they're looking for the open interval. So here, oh, sorry, open interval. All right, let's check the answer. All right, we got that. All right, next question is the function is decreasing on everywhere else, so it's going to be negative infinity to negative 6, comma, 0 to infinity. All right, so let's check the answer. All right, so we got that. All right, so the next question, which statement is regarding the extreme? All right, so we know that here the graph is going to be decreasing to increasing and increasing to decreasing. So you know that here this is going to be a local minimum there, but here. Alright, so function has a local minimum at negative 6 and local maximum at x equals 0. That is false because function is not defined at 0. And the B should be correct. The function has a local minimum at the x equals negative 6. Right? So that's not right. And local extrema, there's a local minimum there. So let's check the answer. Alright, we got that. Alright, that's it. I hope that this was clear.